All right, we didn't schedule this, so we're just going live right away. Nobody's here yet. But if you're watching the replay, what I'm going to be attempting today is I'm going to be printing a bunch of clear PETG. My print here is going to be maybe 12 or 16 kilograms. I'm going to go get the, I'll just take you with me to the other room. I'm going to show you what the printed object is going to roughly look like. This thing right here. As you can see, this was my PLA attempt. It didn't finish because basically I had an issue partway through the print. But this thing is massive and huge and yeah, very sturdy. Lots of filament went into that. But I had an error about halfway through the model where I paused to install larger CHT nozzles, which are now installed. You can see they have much larger holes there. These are the 1.8 millimeter diameter CHT nozzles. So yeah, those will be able to flow a lot more filament. But right now, oh, Gohan, you still haven't made it home. Cool, yeah. Gohan in the comments picked up a printer last night. So anyways, we're going to get this all fired up. I need to switch over to my clear PETG. So let's get to it. We're heating up all the hot ends. We're getting everything all staged and ready. I need to open up 4 spools of clear PETG. Now I'm not sure if PETG is going to perform better or worse than PLA in terms of warping. I think warping was one of the biggest issues that I had last time. So I made the bottom of the can a little bit thinner. I think that should help. And I think adding proper part cooling should also help with reducing curling. But we're not going to deal with all that for now. I think this PETG should be fine without part cooling. So right now the heated bed is going up to temperature. The hot ends are all at temperature. So I just have to load up this filament and press go. So one of the other big problems that I had yesterday was there was no flow compensation for basically accounting for the fact that this bed isn't a bed slinger. It's actually a round rotating table. So yeah, how many mph does it roll? I'm not sure what you mean by mph. Miles per hour. I'm not sure what that would be. But anyways, I've modified my G code so that it should basically be able to account for the change in diameter of where the nozzles are. Took a little bit of math and a little programming, but fortunately I had some help with that, and we're ready to make a really good looking print. That's my goal for today. So Alright, so for those of you who were here yesterday, you know the general vibe of the stream. It's just going to be me wrestling with this giant machine and trying to get it to print what I need it to. So yeah, lots of random issues pop up, and it's a bit of a challenge to get this thing running properly, but you know, prototype machine and all that. All right. 4 kilos of PETG loaded up. For anyone that was in yesterday's live stream, let me know what your favorite moments were from that one. It was pretty crazy. I don't know. It was a little too crazy. But I suppose that's better than being too boring. All right, one loaded up. Two loaded up. I mean, I put this machine through a lot of abuse yesterday and nothing broke, so I think it was a successful test. There was lots of collisions and stuff. There's definitely opportunities for things to break and fail, but they didn't. Other than the print looking kind of like garbage, I guess that's not the best result, but aside from that, everything went pretty well. Okay, got my filament all loaded up. Time to get this party started. Our bed is heating up. Our hot ends are up to temperature. I think I'm gonna home everything and get this prepped and ready for my G-code. So, what's the game plan for today? While we wait for the bed to heat up, I'll just go over it with you. So yesterday, I'll just get the print so you can see it, but yeah, I've done a couple test prints, really big stuff like this. This is a frisbee I can throw like hundreds of feet. It's a very good flying frisbee. Let me get my large test print so I can show you. This trash bin that I'm making, very large, very thick. I mean, just look at this. The base of the print is over half an inch thick. This is about 15 millimeters thick. So this is like rock solid on the bottom here. You can see if I take a screwdriver, you can't break it because it's just such thick plastic. So yeah, this thing was wanting to curl up like a potato chip because of how thick it is. But yeah, I bolted it down to the plate and we got it to more or less print. The main issue was basically when it's printing these features on the inside, it's laying down more material per millimeter traveled. And then when it goes to the outside, it's laying down less material per millimeter traveled. Just because of the way that I sliced this thing, it thinks that 1 millimeter in here is, basically 2 millimeters out here. And it just has to do with the radius of where the print head is relative to the center. So if I try to print at the center, it's going to be barely moving but extruding the whole amount of plastic, and that's not going to be any good. But when I go to the outside, if it's tuned for printing towards the middle, then it's going to be way under extruding. So I did some G-code compensation. We can take a look at the print here. Now you can see this graph is showing the volumetric flow rate, and objects that are closer towards the inside are going to print with less flow rate, and objects further outside are going to print with higher flow rate, and that'll basically compensate for the fact that the radius is changing as this thing's printing. Also, on my previous model, I had it print one swirl, like one twist from bottom to top. Now I'm doing a couple twists back and forth just to add a little bit more patterning to this thing, and also increase the amount of overlap so that those interfaces should be stronger. Okay, so that's the plan. We've got to start up the print over here. Got my filament loaded. I think I'm ready to just hit print on this thing. Except for the fact that the heated bed needs to get up to temperature. So what temperature do I need for PETG? I think that's about 90 C. It should take about, let's see, it takes about 10 minutes to get up to 60 C. And up to 90, it should take maybe 20 minutes. And we've been heating for about 8 minutes. So we've got another 12 minutes for this to get up to temperature. Yeah, so we'll just wait, and while we're waiting, I guess I can read the chat and answer any questions you guys have about the goings-on of today. So let's see what you got. Let's see what kind of questions you can come up with for me. Genius, says Lorenzo. Thank you, thank you. What was the total cost for the printer? It was a lot. We'll leave it at that. It's, you know, each subsystem costs in the thousands of dollars. So funding something like this is a bit of a challenge. I think if I can open up like a print shop and produce parts for people, I'm not sure what kind of things you would want to have made, but I can imagine like wheels and furniture pieces or wall art or something. Just the flow rate and the multi-material capabilities of this machine should make it able to print some interesting stuff. Also the size of the printer. Just being able to print something this large, 600 millimeters in diameter and almost a meter high. I've tested it up to 800 millimeters. So, you know, that's a thing. But, you know, I've got a lot of improvements to make on the machine, and we're still working on it. Let's see what other questions we've got. Yes, Yonora, vase mode. I would like to start doing vase mode on this machine. But going back to the miles per hour, I mean, it's slower than a walking pace. Yeah, so SS1 Gohan 13 came to pick up a printer last night, and that was in the middle of an issue that I was having with those nozzles. Speaking of the nozzles, I think I'm going to do a hot tightening of them, just to make sure they stay on there throughout the print. So to do that, I'm going to turn the temperatures up to 280, and I will give it a little click with my torque wrench here. So let's let that get up to temperature. Of course, I use boron nitride. I've got my gigantic jug of boron nitride paste here so that I can apply copious amounts whenever necessary. Okay, so 265. I'll wait for these to get up to temperature. Just another couple minutes, maybe a couple seconds, really. The heated bed is up to 67 degrees, so we got a little bit longer to go to get it up to 90 degrees. And someone in the comments, if you have strong opinions or knowledge about what the ideal temperature for printing PETG is, for the bed temperature, and also nozzles. Any recommendations that you have will be useful for me. I think on the Prusa machines, they usually set it to 80 or 90 degrees for PETG, and people will say to turn the temperatures up a little bit if you have a larger print. I'm not sure what the science is on that. Okay, so we'll give this a hot tighten. 2 clicks with the torque wrench. I'm using this handy little Slice Engineering torque wrench. I would put an affiliate link in the description below, but I'm too lazy to do that right now, and I'm in the middle of this. So we're just going to leave it without affiliate links. You guys are just going to have to, buy it without giving me a kickback on that affiliate cash, which is awful. It's terrible when that happens. Okay, so I turned the temperatures back down to 260. Now I'm just going to hit start on the G-code now. I think we're ready to go. Alright, we're homing Y. Oops. I need to redo the Y homing. Now we're doing our Z homing. So Gohan got to see this machine firsthand. What did you think of it, Gohan, when you saw it? When you saw this gigantic thingy? Add bathroom exhaust fan at the top for ABS. Yeah, I definitely need to add an enclosure for this. Now this tape is coming off. I think this tape doesn't really stick to itself very well past like 70 Celsius. So that's gonna not be good for bed adhesion. All right, now I think, let's see what's going on. It's waiting for the heated bed to cool off before it gets started, but I actually want to turn it up. What do you think, 80 or 90 C for first layer bed adhesion of PETG? I'm going to see if anyone... 90/240, okay. Bed 80. All right, it'll start out at 70, and then I've turned the temperature up, so I guess I'll do 80 for the bed. I can move it by myself. Yeah, it's actually quite easy to move because it has wheels. See? I've got really nice wheels on the bottom that I can use to level the printer and all that kind of stuff. So, all right, here goes. Gotta make sure that's engaged. All our extruders are engaged. Okay, all of our filament is feeding. Now PETG, one of the challenges I'm going to have is it likes to bubble. So I can't just crank the temperatures up as high as I want and expect it to work. And I'm going to need to adjust all of these relative to each other as well. I'm going to turn the extrusion multiplier up. and I'm gonna make sure these are all at the same X. I didn't build this thing with the necessary levels of precision. Yeah, so hopefully everything's gonna line up. I think I need to up the flow rates a little bit. So we're running at 50 millimeters cubed per second. This is clear filament too, so sorry if you can't see it very well. Invisible ink. I'm going to turn the extrusion up a little bit more. As well as the print temperature, I'm bumping it up to 250. Now I assume you're going to want a close-up of this. Extrusion's looking pretty good. So my hot end setup is 4 tubes from Luke's lab and 4 LGX Pros from Bondtech and 4 CHT nozzles of the 1.8 millimeter variety from Bondtech. And that should help me get as much flow as possible out of these. And if you haven't already, make sure to smash that like button. I don't know what it does, but I guess it helps somehow. So I'm going to be bolting this down to the print bed. You can see there's some holes here, so I can actually install physical bolts to ensure that my parts stick here. And sorry you can't really see what's going on. I mean, that's just how it goes with clear PETG. But I think it's looking pretty good. This one looks like it's a little high, so I'm going to manually adjust it down. We'll give it 2 clicks of downwards motion. I just manually rotate that to get it to be squished down against the bed a little bit more. Hopefully everything's good. So as per usual, we're going to go slow for the first layer, and then we'll pick up the speed from there. Have you implemented your extrusion compensation script today? Yes, demons. I have. So if we take a look at the G code, this is what it looks like. The stuff closer inwards is lower flow rate, and the stuff towards the outsides is a higher flow rate. So, I mean, that should all be fine and dandy. I think I'm running the wrong, I might be running the wrong G code here, but no, I think it's fine. I'm running I did a slight update to improve the performance of the first layer, and this isn't the latest version of it. But this is, it has the majority of the compensations added in. So we're just going to watch this thing print. If you have any questions, let me know in the comments. I'll read off some stats as we're printing along. So right now we're doing 52 cubic millimeters per second of this clear PETG. I'm using this Grant Kit filament. Not because I'm sponsored, but because it's the cheapest stuff on Amazon. All right. I can hear sizzling coming off of all these hot ends. I'm not sure if that's, I think that's got to be from the PETG having a little bit of moisture in there. So maybe I need to get a better PETG supplier that has drier stuff. Or maybe I need some dryer boxes. If I had like a 4-spool dryer box so that I could have like 16 spools of filament ready to load up into this machine that are all dried out, I think that would be ideal. But yeah, I'm going to need a lot of dried up filament at a time to run this thing. All right, our bed is at 80 Celsius and our hot ends are at 250. So right now we're running at a measly approximately 1 kilogram per hour. We'll try and bump that up when we get into the higher layers. Again, you know, first layer quality is super important and all that, so I'm just leaving it low for right now. Okay. I think this one needs to be scooched in one click. Okay. I just let it skip one step to move it inbound a little bit, just because I need all these to line up and stack together. Here you can see the filament getting laid down. Now I'm pretty sure the cross-sectional area of the filament that it's laying down is larger than the cross-sectional area of the filament that's going in. So yeah, definitely squishing out some fat beads of filament. So Nick, my tentative name is the Quadrupolar Express. You know, like the Polar Express, but it's got quadruple polar construction, or just quadrupolar. Oh, Polymaker, if they sent me a pallet of filament, I would definitely use that up. So Vishal, there's no such thing as waste when you're testing a prototype. That is the design engineer's mantra. And that's how we end up wasting a ton of money out of a company's budget. But at least we're having fun while we do it. Here we go. I guess we're printing more stuff now. You can hear all these, this filament is a little bit wet, so you can hear the bubbling and popping. Like if I wanted perfect quality, I'd have to slow it down a little bit and reduce the temperatures. But maybe I'll just try reducing the temperatures and see how that works. I'm gonna turn this down to 240. So printing at lower temperatures also reduces the internal stresses from in your parts because you have less thermal contraction since you're starting at a lower temperature. So hopefully that'll help combat that issue this time around. Oh, and you know what? This is the most updated version of my code. So this is all good. I think I'm going to turn up the speed a little bit. I think it can handle a little more speed. But I can already tell this is going down much better than on my previous attempt. Because that flow is compensated from being more inbound, it's extruding less, and this is just looking a heck of a lot cleaner. So I know this is going to produce a better result than what we got last time. Hey, Grat Kit comes with a little bag too. Look at that. You know, we got our cheapo filament with little cheapo bags. I don't know what you'd use these for, but I guess that's cool. This is looking quite good. This one needs to move that way one click, so I'm going to move it. I moved it one click back to get everything to line up a little bit better. This thing doesn't have as precise of construction as I'd like. So everything isn't stacking up perfectly as it should, but we're doing okay here. Alright, I'll turn up the speed even a little bit more as it goes inside. I actually should increase the feed rate as it moves inbound to do even more compensation in the G-code, just to make it perform even more consistently. But the main thing is that extrusion compensation. That's the most important thing to get this running properly. So I put a high priority on getting that working, and I guess the rest is going to be fine. Nice. Okay, I'm going to read the chat for a little bit, see what you guys have to say. Peso Pluma haircut? Yes. I don't know where the haircut came from. I think someone snuck in and cut my hair while I was sleeping. Does this setup require a circular build plate? Yes. I mean, it doesn't require it, but it's going to be better to have a circular build plate because you're going to be using space more efficiently. Yes, tube to the 4th quadrupolar express. We're calling it a series of tubes in parallel. Can you make a bamboo with that printer more efficiently? I'm not sure. This thing brings me back to the days where we were wondering if Etch-a-Sketch could be used for printing. Alrighty. Quadra Cubic Express. Name ideas? Choo Choo or Choo Tube? Yeah, that's good. you know, you got trains and tubes and all that together. Yeah, so any other questions? Start blowing quadrocopter like. Etch-a-sketch lead to core XY. How long did it take to design this? Well, it's been a concept I've had for about 2 years. I've wanted to build something like this. But I really started, you know, taking the idea seriously like 6 or 7 months ago when I was at when I was at Formnext. I saw all these people building and selling printers, and I'm like, these aren't even that innovative. It's just another Core XY printer with slightly different parts than the next guy. So I'm like, why don't I just make something completely wacky and wild and see if anyone wants to mess around with it. Okay, this wire needs to behave a little better. Put some zip ties on it. There we go. It's a little cable management. Now it looks like for whatever reason this hot end over here is running a little bit hotter than the rest of them, or the filament has a lower melting point. Something strange is going on, so I'm going to turn this one's temperature down a little bit. That's hot end 0. We'll bump the temperature of that one down 5 degrees just to bring it more in line with the others. We're still printing at 53 cubic millimeters per second up here. If anyone was watching yesterday, you'll notice that this is way less hectic. Like, it's just working a lot better. Now I might need to slow down a little bit. It's going 75 millimeters cubed per second here. I think I need to slow it down a little bit to just get excellent first layer quality. That's the name of the game here. We want excellent first layer quality so that we're going to have less issues with the bed coming detached later. And as usual, we're going slow for the first layer, and of course that's more boring. But if you're watching this back on a replay, you can skip forward. All the suckers that are watching this live are just gonna, watch this gigantic pizza platter spin around in circles for a while before anything interesting starts happening. But you guys that are watching live are also the best. So thank you for joining the adventure today. I swear it's printing. Maybe this clear filament wasn't the best choice for a live demo, but I'll read the comments for a little bit. Sorry for not making it more entertaining. I think I've got this down to a science a little bit. Interesting idea to more quickly print something with common geometry around the center point. Yeah. Vishal, yes, I did design this by myself. How long did it take to design it? Well, I did about 10 iterations in CAD to come up with this overall layout. And that's not to say that it's the perfect design. I mean, there's definitely a lot of different ways to do this that could be better or worse. This one, I just focused on making it as simple as possible. Just like a really easy machine to understand, troubleshoot, and work on. There's other iterations of this machine that, would be much more structurally wise. But this one is just, like, very simple. You can see how it works, right? Not too complicated. It's just four, essentially, Prusa minis arranged in a circle. Uh-oh, we had some skipped steps there. Uh-oh. Wait a minute. Okay. Alright, I think it was just extruder steps that were skipped, which is not that big of a deal. I'll turn the speed down a little bit. The extruder skipping steps is probably the least of my concerns. The main issue that I could have is when these axes skip steps, because then that breaks them all out of synchronization and it can ruin the print. Ah, okay. I forgot to clean up those spools. I don't know if you can see them. That's probably what was causing the issues, so I'll just... Forgot to take these little bits off. Okay. And we'll resume watching the print. Let me know if there's anything you want to see closer up, like if you want a close-up of the nozzles, or you want to watch the filament being laid down in real time. You want to watch the spindles of filament spin around as they're sucked off of the spools. All right, Hattie, yes. Benchy in the middle. Okay, all right, sorry about that. My sincerest apologies for not having the benchy in the middle. And to go with our clear filament, we have a clear PETG benchy to put in the middle. Here we go. So how many cubic millimeters of filament are in a benchy? Because I bet we're consuming like a benchy of filament every minute, at least. Wow. This is going to be amazing when it's finished. The clarity of these PETG parts, super nice. So if this trash can turns out nice, who wants to buy it? And what should I even charge for something like this? Hello TNX, welcome back. The previous one did not reach the finish line. It had an undisclosed error. Here's the previous one. Because it had some issues. We'll leave it at that. But those should all be fixed on this one. We should get much better results now. But yeah, this is a seriously chunky print. This is about 8 kilograms of filament. Yeah, it's solid-ish. There's a lot of under extrusion going on here because of the way that I had to do the extrusion compensation. Now I've got that taken care of on this one, so it should be solid all the way through. Isn't clear the most exciting color to watch print? Yes, exactly. This will be worth millions, I tell you. We need more salesmen like TW there. Don't think of it as a trash can. Think of it as an investment in your future, in your portfolio of assets. Yep, it sounds kind of like bottles being crumpled up. The build plate is 600 millimeters in diameter. The world does revolve around a benchy. Yes, that's right. Next up, I'm going to print a scale model of the flat Earth. We've got the perfect blue backdrop for it, and we'll just load up some Polyterra green, maybe some brown filament for the mountains, and then white filament for the polar ice caps that surround the perimeter of the world. Do I have enough clear filament to make a completely clear trash can? No, I don't. I don't have enough clear PETG to keep this going indefinitely. But at least the bottom's going to be clear. And maybe I'll have one spiral be clear going up through the trash can. But I'm going to have to switch to a couple different colors. I'll show you what I have for PETG in a minute. Look at that cross-hatched pattern. That's trippy. Okay, I'm going to speed it up for these inner layers. Again, I'll have my compensation code automatically speed things up towards the center. But for now, I've just got the extrusion compensation, which was the most important. And I didn't feel like messing around with the print speeds because that seems like a good way to ruin everything. All right, let me catch up with the comments again. How's everyone doing today? We've got a lovely Saturday afternoon to kill. Do we have enough? Yeah. How long should it take for the full thing? I'm not sure. Let me take a look at my slicer. So the slicer is saying it should take 11 hours, 25 minutes. But I think I can increase the print speed by about 50%. And that will get me the result in 9 hours, more or less. So the bed is heated. I have a heated bed down there. It was a little complex to get the heated bed to spin like this, but it's very important to have a heated bed for large prints, so I figured it out. Altogether, it looks like this is going to take 3.5 kilograms per print head. What does that end up being? Times 4. So 14 kilograms. Hopefully I have enough PETG to make this happen. The print head can reach the center. They can't all reach the center at the same time with the current design, but it would be trivial to redesign it such that they can all reach the middle at the same time. The thing is you don't have very much velocity when you're at the middle of the bed, so you don't really need all 4 printers going at the same time. It's most important to have 4 printers towards the outside. So in firmware, I could, in the future, disable 2 of the heads and have 2 of them get like right near towards the middle, then disable 1 head and just have a single one do the very center of the plate. Yeah, there's a lot of optimization and stuff that can go on with this design. There's always going to be ways to make it better. Wow, these are super clear layers of PETG. It's going to be a shame to use this thing as a trash can at the end of the day. It's so pretty. You think it looks like a glue gun? Well, the original inspiration for a 3D printer was, in fact, the glue gun. Alright, so I'm going to do a little trivia. It's trivia time for those of you in the comments. When was the glue gun invented? Does anybody know? When was the glue gun invented? Now, some smarty pants is going to ask ChatGPT. I know it, but, oh, 54. Okay, Butta Sticks. That sounds like someone who looked up the answer online. All right, I guess trivia doesn't work very well in an audience that's completely, you know, sitting on the internet. But that surprised me. I thought the glue gun would have been an older invention than that, because that's something that when I went to school, it was ubiquitous. Like everybody knew what a glue gun was. But they probably didn't become like a household object until the 80s or 90s. And I think we might see the same thing with 3D printers. Maybe 3D printers will be a household/classroom object in the next 10 years. I'm just cleaning up my chamber pot here. Yeah. I need to take this to a belt sander or something. This is pretty tough to cut through even one layer. We'll have to revisit that later. All right, and we also need a rubber ducky. There we go. Maybe big ducky too. A pizza in the middle. Ducky's a good compromise for pizza. Oh yeah. That sounds like it could work. It could also be very dangerous and something that I don't want to do right now. Or just, oh crap. I feel like it's gonna cut holes in my clothes. All these sharp edges. Yeah, I definitely need to clean it up. No secret plan to print rockets? Oh, I mean, I guess it could do that. I never thought about that. Interesting. All sorts of circular objects could be printed on this. All right, well, I would have never thought about that. Nathan builds robots. Yes. Huh. I mean, you could easily make some disposable rockets on something like this. Wow. The optical clarity on this PETG is mesmerizing. Let's take a look at that. Yeah, each hot end could produce a different wall. The first test print that I did was to print 4 identical objects at the same time. I can also do vase mode where each one prints its own layer of a vase. So I could make a 4-walled print in vase mode. And it would be very strong because, like right now, each layer of filament that I'm laying down is 3 to 4 millimeters thick. So that's like 1.6 centimeters, over half an inch thick vase mode parts that I could make with this. Those would be extremely strong. Thanks, Okano. Yes, I am more than all talk. Yeah, so each layer is 3 to 4 each bead of filament that I lay down is 3 to 4 millimeters thick. Multiply that by 4 because I could have each one printing a parallel wall that are all fused together. And I could make parts that are, I mean, I could even step it up so that it's printing vase mode 1 inch thick, which would be insane. Like, it'd be very strong. Yeah, that's what I'm saying, Hattie. This thing is cool and useful. So, yeah, I want to open up Nathan's print shop. And you'll be able to order parts that are printed extremely strong and thick. Initially, it'll probably be simpler geometry, like these things that are symmetric, either circularly symmetric or 4-wall symmetric or octagonal symmetry or 12-sided symmetry. Basically, any factor of 4 you can do symmetric with a simple version of firmware running on it. But eventually I'd like to scale it up so that it can do any object. It'll just be a matter of improving the firmware and the software used to slice it. And I could print any shape you want using this 4-print head approach. Cool and useful for thick trash cans, yep. And that's what we're printing today, some THICC trash cans. Okay, so I don't know if this is properly captured by the static camera angle, but like this is trippy. Do you see that optical effect? Maybe. You see that? This is what I'm looking at, and I'm like kind of tripping out over here. Yeah, I thought about having a delta in the center. Do you know what the problem is with that? 104? I want you to try and tell me what the issue with making this thing a delta would be. I could print a Fresnel lens on this machine. Like a gigantic lens that could focus, you know, this whole magnified area down into a point. I could melt some stuff with a 3D printed lens. That could be a fun video. So, Yunora, they wouldn't necessarily hit each other if you programmed it right. Too many legs. Yeah, I mean, technically you can build a delta printer that uses 4 legs instead of 3. It would be a statically indeterminate structure, but that's actually a good thing in a lot of applications. It adds extra strength and rigidity at the cost of having an extra motor and bearings. So the main practical reason why I wouldn't want to put a delta in the middle of this thing is because it would have to be twice as tall. Because to have the delta be able to print up here, it would have to have like another meter of height on top of this machine. So then it would be like okay, we're back. Sorry about that, guys. Sorry. I know it sucks when the audio goes out. Can you hear me now? I was getting a call. So, yeah, basically I need to make dinner reservations tonight. And that's going to... Yeah, I know. We're going to lose a lot of viewers because I need to call and make dinner reservations. It'll just be a minute. The stream will stop. Unfortunately, I'm using my phone for all of this streaming stuff. So I will be right back on. I just beg of you to please have patience. So yeah, I'm going to call, make dinner reservations, and then I'll get back on the stream. And hopefully we'll have more than 2 people left watching after that. Yeah, we're going through a tunnel. So let me just give you a brief update as to where we're at in the slicer here. So according to fluid, we're working on layer 4. So this is layer 4, looks like. We're actually done with the we're done with the solid layers. Everything after this is going to be walls, and things are going to pick up in speed. So, yeah, things are going to get fast shortly here. Yeah, we're going to try and go fast. I improved the slicer. I did the flow compensation, so now it shouldn't be over and under extruding all the time. It'll actually just be extruding perfectly, which, you know, ideally that's what you want in a 3D printer. But hold on for just 1, possibly 2 minutes while I make dinner reservations. I'm sorry, guys. I do like to eat food. Sometimes I like to eat food at other places other than my office on the floor here. As you can see by my enchanted jangle on the floor. I do eat here sometimes. But going out to eat tonight. So muchos gracias for staying with me through the temporary blackout we're going to have. Don't worry, we'll be back. And I'll try and throw in a little surprise for you guys by the time we return. So yeah, 1 minute, we're gonna lose audio and video. I just gotta make a call for 30 seconds to a minute, okay? All right, BRB guys. We're back. We're back. How many people did we lose? Oh, we only lost 6. You guys are absolute legends for sitting through the tunnel time, as we like to call it. Okay, so we're printing along still. Everything looks fine. I think we're going 69 millimeters cubed per second. And I'm not even like cranking the temperatures up that high yet. Maybe I should. Okay, I just bumped the temperatures up 10 degrees, so now we're at 250. Oh no, we lost a ton of people. Oh no, everybody was like, blank screen, I'm out, later. I don't care if history is being made. I've got to watch some TikToks. Nappin, thanks for joining. You're helping boost our numbers back up. Okay, so we are finishing up our last layer of solid material at the bottom, and we're gonna switch over to, as you say, walls. The walls. All right, and while this is going on, I should also figure out, oh yeah, I definitely plan on enclosing it. It's not enclosed right now just because that takes extra time and effort, and I'm just trying to test as much stuff as possible. Yeah, the print is looking much better than yesterday's. Okay, so, everybody, time to go over our filament selection today. And by selection, I mean you don't really have many choices because I'm running out of filament. All right, so we've got 2 clear PETGs. We've got a black PETG. Let me go get some other stuff. We've got a magenta clear PETG, another black, and 2 white PETGs. So I think I need at least one more spool to have any hope of finishing this print. I'll see if I have any in here. Yeah, this isn't looking good. Yeah, I'm probably going to run out of filament. At least out of PETG. So we're going to have to figure out a good substitute. Does anything stick to PETG that I can use? I've got a bunch of PLA, but obviously that doesn't stick. PLA. Crap. Okay, so I've got a silver PETG here. Yeah, I think we might have an issue where we run out of filament. So I might need to make an emergency trip to Micro Center. Oh, crap. Okay, I need to slow down a little bit to get better. Get better extrusion quality here. So if I ration my printing, if I ration my filament properly, I might be able to get by with what we have. They'll be cutting it close though, so I'm going to try and find some more PETG around here. I have a bunch of nylon. Does nylon stick to PETG? got a little more here. This isn't going to do much, but every little bit's going to help here. I have TPU, Polyterra, Silk, PLA, ABS. I think I'm just gonna cut the flow ratio down a little bit so it won't be extruding as much plastic when it's building the walls, which will make it a little bit thinner and weaker, which I don't like to do, but I think that's what we're gonna have to do to make it work. We'll see what happens. This will keep you guys on the edge of your seat. I mean, as exciting as this is, I think having a little extra excitement might be good for the stream. Keep you a little more invested in the story. You know what I mean? Rip your V02 apart and turn it into an EDM machine. Nice. I've got a full spool of jet black. Oh, nice, Joe. Thanks. We'll see what happens. I think I need to do the math, but I think it might just barely work out. Like, it's going to be one of those situations where the last bit of filament is going to be fed off of the spool, and it's going to get right to the end of the extruder right before the print finishes, except it'll be that times 4. So this is going to be epic. The ducky approves. All right, so we're now printing the walls. Yes, so good. It just works. It's like a bamboo. Except I decided to use lower voltage for the bed, despite it being bigger than the A1's bed, because I don't want anyone to get electrocuted working on my stuff. Okay, so we're printing at 60 cubic millimeters per second. How's our quality look? I think it looks pretty good. there's always going to be the temptation to increase print speed and sacrifice quality. Maybe we'll get to that point in a couple layers, but right now I'm just enjoying watching it print really nicely. Okay, I decided to slow it down a little bit and also lower the temperatures just to see if we can improve the quality. I want to see what like maximum print quality looks like on this machine. So we'll print like this for a couple layers, a little bit slower, but with better quality. We're getting low, everybody. All right, so I turned it down to 40 cubic millimeters per second, and I turned the temperatures down just to hopefully reduce the amount of bubbles. So I just want to see what like max quality looks like. I probably won't be able to see it very well just because everything's covered up by, everything's invisible essentially, or transparent. So it's really hard to see what's going on, but I don't think it's significantly different. It's just nice. Everybody likes this POV. Thanks, Green Dragon. Come back. We'll show you some cool stuff when you're ready. This is fresh filament out of the package. It's also the cheapest filament that I could find on Amazon, so you get what you pay for. You can definitely hear there's some water trapped in there. Holy cow, that's so glassy right there. It doesn't really come across on camera. It's too shiny to really understand what that looks like in real life, but it looks real good. Hold on, I know what this live stream is missing. This has been the most popular request for this machine since I announced it, and I'm sorry for leaving it off for so long, but it's time. Ah. You guys need to see what's going on. This is history being made right now. This is going to make the printer at least 3 times faster. Ah, ooh. But that's hot. If you know what's coming, you know what's coming. You just know. right, who's ready to witness the future? Who's ready to bear witness? What do you think? Much better, right? I mean, you can see the speed increase. It's not even like close. This is clearly much faster. I'm just making sure this LED strip doesn't ruin the print. That would be the worst outcome. All right. Okay, so that's it. Now we can just watch the trippy colors. Oh, crap. What's going on now? Oh. Hello? That's not good. What's wrong with my LEDs? Sorry about that, guys. I don't want anyone having a spasm attack from these lights going crazy. Let's try some different visuals. Okay, I need to increase my extrusion multiplier. Which is making things look even worse for my ability to actually finish this print. But this is how we do it. Oh, I think there's some kind of short circuit. No. I think I fried my LED driver by having a short circuit. No! The whole strip's messed up now. Ah. Why? Well, that was fun while it lasted. Maybe we'll get some more LEDs later. All right, I'm going to turn the speed up a little bit. We're doing like 60 to 70 cubic millimeters per second. I turned the speed up to 270, or the temperature up to 270 to get better melting at these higher speeds. .78 cubic millimeters per second. Okay. This is awesome. All right. Anything going on in the chat? I'm just watching this thing. All right, that's cool. Just watch the printer go. That's I guess that's all I need to do. I don't really need to do any commentary or anything. You guys good just watching this thing? I can go do something else. Okay. All right, well, I'm just going to leave this running. You guys have fun watching the printer. In about an hour, I'm going to need to switch over the filament spools. But as far as everything's going right now, we're printing at 70 cubic millimeters per second, which translates to a little over a kilogram an hour. Still not that 2 kilogram per hour mark that I want to hit eventually, but PETG kind of likes being printed a little slower. Hopefully we don't have any bed adhesion issues. I think that's the only thing that could really derail things at this point. So we'll just keep our fingers crossed and hope everything goes well. Wow. I'm just marginally increasing temperatures and speeds. Trying to get the most out of this machine right now. Reminds me of Castle Walls. Do you need custom software to run this, or does it work with Marlin or something? I'm running Clipper, and it's working okay. It's not great, but it's okay. I'll say that much. So I didn't do the flow compensation perfectly, and I can see the evidence of that. On the outsides, it's looking a little under extruded still. On the insides, it's looking pretty good. But also, we're just having some print quality issues that come from trying to print so fast. So right now, we're going 85 millimeters cubed per second, which is very fast for PETG. I'll try bumping the temperatures some more. I don't think it's a great idea, but I'm just curious to see what happens. So we'll go up to 300. So now we're printing PETG at 300 Celsius at around 80 plus cubic millimeters per second. Uh-oh. Oh no. Crap. All right, so I think this was a pretty successful test. I'm actually going to call it quits here. Everything, the extrusion compensation worked out. The issue I ran into today is ADC out of range. I set it to 300 degrees, and I also set the max temperature in my clipper config to 300. No, it wasn't thermal runaway. It just, yeah, I set the max temp to 300, and then I told it to go to 300, so it ran out, like it overshot by 1 degree, and that was enough for it to be like, I'm dying, and it quit. But yeah, this is a pretty cool test print. I'll get it one of these days. I think this turned out a lot better. I can tune my extrusion compensation a little bit. And yeah, the thing is I've got a lot of stuff to do before I move, and this has been a little project that I keep procrastinating by working on this. But, you know, we're getting a little bit further every time. I think this was a much better result than what I got last time, although I just had the printer, you know, stop working. But yeah. Yeah, there's lots of config problems that can pop up in Clipper, and then you start pushing things, and then Clipper's like, I'm going to quit working because that's clearly a good idea right now. But let's get this thing off the print bed. And I'll also stock up on PETG so that I can do a full 14 or so kilograms next time. But I verified that the extrusion compensation code that I wrote works, or, you know, actually my brother wrote it for me. And these stepper motors are getting really hot, so there's just a lot of things that I can improve on this printer. And I need to start, you know, keep testing it and also design the next revision. Lots of stuff to do. So I'm going to turn the fan onto the printer. And we'll cool off that heated bed and see if I can actually pop this thing off of the build tray. That might be a challenge. Yeah, this thing's stuck on here pretty good. I'll have to wait for the bed to cool off. Or I can turn on these part cooling fans, which is another thing that I need to fix on this printer. These part cooling fans are a little too strong, so I need to figure out how to turn them down a little bit. All right, firmware restart. We'll set these fans all the way on. And that should help cool things off a little bit. Hold on, we gotta add a little spinny action in here. All right, let's pull this thing off. right. There's our second massive test print. This worked out pretty well, I think. Still not a finished print, but you know, each time we have a little F up or a little mistake, we learn another weakness of the machine. So, got to fix that clipper config to allow me to go up past 300 Celsius. And there's some other stuff to work on. But as far as, you know, most of this goes, it's working pretty well. Anyone have any comments in the chat about this thing? Oh yeah, I put bolt holes in here to bolt a bottom onto it. Print some wedges, yeah, that would work. Yeah, I tried the donkey kick, it didn't work. Let's see how strong this thing is. I mean, it's kind of cool optically. You can see pretty much right through it. This is 3 layers at about 2 millimeters per layer, so this is 6 millimeters thick. Pretty strong. I think my extrusion compensation was pretty much spot on, but it needs to be dialed in just a little bit to be perfect. But we can get there. Next revision, I'll definitely have it. How strong do you think this piece is? I bet I could drive over it. Yeah, it definitely is a lot better on this one. And there was no like crazy collisions going on. It just all went down pretty much as planned. Wow. So this print, this took 2 hours. So this gigantic thing, it used about 2 kilograms of filament and took 2 hours. Lovely stuff. I'm sure you could stand on it. Yeah, I could definitely stand on it. Oh. I definitely need some power tools to do post-processing on these parts, just because this 1 layer thick brim is pretty strong. This is like, you know, I think thicker than a credit card. All right. So, any other questions before we pack this one up? I want to do 80 cubic on my hot end. How do I do it without looking as bad as yours? Don't do PETG mainly. I could do decent looking 80 cubic on PLA or ABS, but PETG just likes to go a little slower. And also, like, just inherent to the prototype of this being a prototype, and you know the spools all tugging on the print heads, it's causing a lot of like inconsistencies in the extrusion in terms of the motion of the print head. So that's reducing the print quality. If I just had this on a normal type machine, this same setup, I'd probably be getting better results off of it. Now people tell me that PETG doesn't shatter like glass, but you've got to be pretty dumb to think that this doesn't shatter like glass. Just look at it. This definitely shatters like glass. Like, PLA doesn't fail like that. Need to get some PETG now. Thanks for ASMR also. You're welcome. Where do you mount? Yeah, so the spool mounting location isn't super important. As long as you're running, like, I can just run Teflon tubes or reverse Bowden tubes down to the extruders, and I can put them pretty much anywhere. They'll probably be up top, on top of the machine. He erroneously set the hot end temp to 300. Yeah, that was it. I set the max temp to 300 in Clipper because I thought I'm not going to go above 300, but you know, then I decided to try that, and it didn't work out so well for me. You could do like flint knapping to make parts out of this stuff. Just shatters. Yeah, and I definitely want to sand all these edges down so I don't cut myself on this part. But big strong part. Woo, woo. If it's printed in thin enough layers. Hold on. You should try tuning for crystal clear printing. Should be possible. Yeah, I could. It's almost there. I need to over extrude a little bit more and clean things up a tiny bit. But it's pretty close. Like, this is quite good. Whee! Alright, cool. Well, if there's no further questions, I thank you all for joining the live stream today. We got to see some more cool stuff. And in about a week, I'll have this thing up and running again. I have to move, so I won't be able to make any content for a little bit while it's in transit, and I'm finding a place to set it up. But should be interesting. Been a fun 3 minutes. All right, Siafu. Well, you came at the wrong time. If you were here 2 hours ago, you would have got to watch all this print. But you can watch the replay, so it's all good. Cool. Well, I'll see you guys in the next live stream. Hopefully, we'll be able to get this thing to print the entire trash can next time. That'll be our goal. All right, Toasty Boy, see ya. Thanks for joining. Doop. Later, everyone.